No. Then do you need more, or are you good for a little while?
Yeah, what?
You're good for a little while, right?
I'm great.
I just thought I don't yeah. Oh.
How's everything? It sounds like they're having fun. Should I go check that out? Give us the deets. Give us the tea. Okay, so here's what we have to do today. I want to teach you the rapido integration by parts technique, just so you can see it. And then we're probably going to start working on the next section, which is integrating powers of trig functions, which we kind of have done a few of those like already. We didn't officially title it, hey, we're integrating powers of trig functions now. And I think we're going to have a quick little quiz on integration by parts tomorrow. So how about that? That's going to be fun. Hopefully you spent some time yesterday doing integration by parts, not sleeping all day long. Yeah.
Will we be able to use like the shortcut on it, or will we have to do
You mean that I'm going to show you right now? Sure. Now this shortcut that I'm going to show you, it really doesn't. It works really nicely on certain types of integration by parts problems. Like the kind where you have to like solve for the problem, where the original problem pops up and you have to solve for it. It doesn't work so nicely on those. But well, let's see what we got. Rapido integration. So we'll just jump in with like a quick example. So like, how about x cubed e to the 2x? Now, if you've been paying attention and you know what you're doing right now, you probably could look at that or should be able to look at that and say, I don't want to do this because I'm going to have to do integration by parts 3 times. And that's going to be a hot mess. Right? So here's where the shortcut method is helpful. So how it works is you make a column for u and you make a column for dv. Okay? And then you put what your choice for u, what it would have been. What's our choice for u? X cubed. What's our choice for dv? E to the 2x. Okay? Then, in the u column, you differentiate this all the way down until you get 0. So 3x squared, 6x, 6, 0. Yeah? Then on this column, you're going to anti-differentiate that all the way down. So this will be e to the 2x over 2, e to the 2x over 4, e to the 2x over 8, and e to the 2x over 16. Did I do that right? Now, some of us might be looking at that and being like, where those 2, 4, 6, 8, 16, where those numbers come from? Where those numbers come from?
When you take the derivative of e to the 2x, so the candle is going to be 2 next to it, so to get rid of it, you have to divide.
So yeah, I mean, it's the anti. It's like every one of those is a little u substitution that you're doing in your head, right? So everybody cool now? Next step of this rapido is you start here and you draw an arrow from there to there. You leave this guy's a loser; he gets left out. Okay?
I saw this on TikTok, and I was so confused because I was like, well, that's not what it was.
Speaking of TikTok, I just learned that you are famous. Like, I mean, you are really famous. Like, holy crap, famous. Like, you might be the most famous person I know. I think I want to get my picture taken with you. She has like 1.3 million followers on YouTube or TikTok. Yeah. What do you have on YouTube? Like, we were watching you at dinner last night. I came home and told my daughters, I'm like, this girl, my cousin's has 1.3 million followers on TikTok.
At least 75, but it depends on brand deals.
Can I help you out? Like, can I do some clicking and get you some more money, or?
Yeah, you can like my videos and watch them and stuff.
I asked my younger daughter, I was like, did you follow Becca? She's like, no, that would be weird. I said, Kate, do you think she has a clue that you would be following? She's like, she would get a notification. I'm like, it's probably turned off at this point. Oh my gosh. So you saw this little rapido thing on TikTok?
Yeah.
Wow, well, you need to make a TikTok video about it that explains it better. If you didn't understand it, then you should make one that explains it. Yeah, I mean, Becca, I think you really might be the most famous person I know. All right, so you draw lines like that, right? Now, you could draw a line back to 0, but it's stupid, okay? You don't need to. So ready? We have that. Then I'm going to put a plus, minus, plus, minus. Okay? And then the arrow means multiply. So it'll be this times this. And then minus 3x squared e to the 2x over 4 plus 6x e to the 2x over 8 minus 6 e to the 2x over 16 plus shares. That's the answer. Okay, now you can see why this might be kind of weird if you had the original problem, came up, or if you had to reassociate factors, which maybe I'll do one like that in a second. Yeah, it really works nicely when you have a polynomial and an exponential, like e to the x or e to the 2x. It might not work so well if you have an e to the x squared. Because the antiderivative of e to the x squared is not one that we just can do easily. It also works nicely when you have like a polynomial like x cubed or x squared with a trig function like sine or cosine. Okay. So we'll let you guys try one just for funsies here. Ready? Let's say 3x cubed cosine of x. Try that one. So make a U column and a DD column. Differentiate down to zero. So what happens when you have two negatives? Like when right here, when you got a minus minus like there, that's going to make it a positive, right? So you can look up here and check yourself when you're done. Questions on that? No. Bless you. So we feel good about that? We like Rapido?
Yeah.
I don't know if any of you guys have ever seen the movie Stand and Deliver. Probably not. The only time you would have ever watched it is in a math class. Stand and Deliver is a movie that was made probably in the mid to late 80s. It tells the story of this math teacher who goes into essentially inner city Los Angeles and in a school that's really struggling and teaches these kids that are mostly Hispanic AP calculus. And he has a pretty small class, and they, these kids come in, they don't even know how to add and subtract. And he works with them over the summer and teaches them AP calculus, and then they end up taking the AP test, and then they get accused of cheating because they did so well. And in that movie, there's a scene where this is written on the board, like this kind of thing. And he calls it tic-tac-toe. He's like, tic-tac-toe. And, the kids are all, there's music playing. This is the moment, where they're building up to because they get accused of cheating, and then they have to retake it. The college board comes in and says, you guys cheated, you have to retake the test. So, you can watch it. I won't spoil it, but you can imagine what happens. But then that guy became famous, and the AP calculus program at that school just took off. And then within 10 or 15 years, they had hundreds of kids taking AP calculus at that school. But anyway, okay, let's do one other integration by parts problem and then I'll answer some questions of your guys' if you have them. But I want you to see where this little Rapido thing, where it might be tricky. Where I would not recommend doing it because it takes too much thought. Rapido should be rapid. You should be able to, just go through it. You don't want to have to sit and think about a shortcut. So let's try. I got to think about this for a second. You guys remember borrowing when you learned how to like subtract? In like 5th grade, or 4th grade, I don't know, whatever that was. Borrowing. Now they don't call it borrowing anymore. They call it regrouping. Which even that's a kind of a weird term to use. But what did you do when you borrowed? Do you remember that? Like, so if I was going to take like 50 and I was going to subtract 19. Okay, first of all, I'd probably just do that on a calculator, wouldn't I? No. Yeah, you say, well, I can't. I'm gonna rethink about this 50 as 40 and 10. Right? Now, the problem with this is years ago, like when I was a kid, they didn't really teach you you're going to rethink about this 50 as 40 and 10. They just said, oh, you just do this. And now you subtract 10 minus 9 and get 1, 4 minus 1 and get 3. And they didn't really tell you why you did any of that or what was happening. They just said, do this. And then you get half the kids figure it out, and then the other half the kids like have no idea what's going on, and they can't figure out why it works, and they don't understand why it works, and then they don't know how to do it. Like, but that's regrouping, right? You took 50 and when you put that 4 there, you're really thinking of 50 as 40 and 10. Okay? So right here, we're going to think about this in a similar way. What do you want to do initially when you first look at this? Like, if you're going to do this by parts, what is your initial, like, I want to make u this and dv this? You might initially look at this and think, I want to make u x cubed and dv e to the x squared. But there's a problem with that. You don't know the antiderivative of e to the x squared. In fact, FYI, e to the x squared doesn't have an antiderivative in closed form, like where it's written as a function like that. Okay? Yeah.
Why wouldn't it just be e to the x squared over 2x?
Because the derivative of that is not e to the x squared. Because of the chain rule.
Because it'd be next to 2.
Yeah.
Right?
Well, if you said this, Becca, e to the x squared over 2x, like you're thinking like when it's just a 2, you divide by that. Really, you're doing a u sub there when you do that. If you thought this was it, if you take the derivative of this, you've now got a quotient rule problem. Right? It's not going to come out back to e to the x squared. Okay? Yeah.
Can you natural log? You have like 3 natural logs.
Well, I can't just natural log something for the heck of it. There needs to be, you can natural log when you have an equation, like you can natural log both sides. You can put something in exponential form, but I can't do that here. I don't have an equation to rewrite it. Okay? So what I'm going to do, put e to the x squared, if there was something next to it, could you find the antiderivative of it pretty easily? What if I thought of it like this? Are those equivalent? Yeah? But now, this guy right here, if I let u equal x squared and dv equal x e to the x squared, what's du? 2x. And what's v? I can do that now because that can be done with this substitution. Maybe we have to do it over to the side here. If I'm going to work this out to the side, u would be x squared. Du is 2x dx. So du over 2 is x dx. So that's e to the u du over 2. So what's the answer there? 1/2 e to the x squared. So if dv is x e to the x squared, what's v? One half e to the x squared. Okay? Somehow set it up. U times v minus the integral of v du. And if I actually clean that up a little bit, what's left here? You clean that up. Becca was the one yesterday who wanted to cancel all that stuff, right? Or, sorry, Tuesday.
E to the x squared.
Isn't that just x e to the x squared? And didn't you just do that? So what's the antiderivative of x e to the x squared? One half e to the x squared. Do you see the connection to borrowing or regrouping? Did you see that? Like that's what you're doing there. You're saying, hey, I've got x cubed here, but I need one of those. I need one of those x's. Because just like right here, I couldn't subtract 0 minus 9, right? So I regrouped, and I said, okay, I'm going to think of 50 as 40 plus 10. Well, same thing here. I can't just anti-differentiate e to the x squared. I need an x next to it. So I'm going to think of that x cubed as x squared times x. Okay? This is called like reassociating factors. Okay, fancy term, but you don't need to know that necessarily. But it's borrowing. All right? Okay, are there any others that you want me to work out from your homework? I got only one person yesterday reached out to me to do any problems for them from both classes. So I didn't know to be concerned or elated. Yeah.
How do we know when to use the Rapido one and when to use
So like, are you looking at this one and thinking, why couldn't we use the Rapido?
Yeah.
Okay, you could. It just involves more thinking. Like, I personally wouldn't use Rapido on this one because I want to use Rapido when I can take these two things and just separate them out and not have to do anything else fancy. And I know the one's going to differentiate to zero. Okay? If with this one right here, if you just jumped in and tried Rapido, you would have done this, right? And then you can't anti-differentiate that. So if you were going to do Rapido, and I've seen books teach it this way, they actually do it like this. They separate it out like, and then they go down, and then at midstream, when they differentiate, they write a new line and then take one of those x's and put it on the other side. I think that gets a little complicated, like because I don't want to be thinking a shortcut should be short. Like it shouldn't be like where you have to like, wait, what am I doing here? Oh, I can't do this now, so I'm going to take one of these. You might as well have just done it the other way. Okay. I would only use the Rapido when you have like x squared, x cubed, or whatever, times e to the x, or e to the 2x, or e to the 3x, or x cubed, x squared, whatever, times sine x or cosine x. That makes sense. Other questions on the homework problems, or any of those that you want me to do? Yeah. Tell me what it is. Just it'll be easier. B?
B.
B as in boy.
Is E. Okay, you know, I'm trying to describe this. Like
Oh, the
okay.
bounds. The integral from 1 to E of, okay.
Natural log of x squared.
Is it of x squared or is it natural log of x squared?
X squared and then.
Like this?
No, like that.
So it's like this.
No, wait.
Only the x's in parentheses.
Yeah.
With the two.
Then it's the first one. The squared is not the whole, like the whole. Natural.
Who's getting squared?
Just the x.
Just the x. So it's just like this. Oh. So are these two the same? No, we need to fix that right now. Are these two the same?
Yeah.
Yeah. Okay. The argument, like what's getting logged, is x squared. Right? The inside of the log is x squared. Why is that different than that? Because that's the log of x squared. All of that squared. Okay. Now we got that fixed. So I think the first step of this, Ellie, is going to be use the property of logarithms. Makes this a little easier. Okay, the log of x squared is the same as 2 log of x. Right? So I can take the 2 out. And you probably want to have the antiderivative of natural log in your hip pocket. Or your front pocket. Or your back pocket. Or your shirt pocket. Any pocket. Maddie knows it. Don't you? Oh, I thought you were like wanting to put your hand up like, oh, I know this. What's the antiderivative of natural log of x?
Ln minus x.
Minus x. Good. So it's x natural log of x minus x. Now we got that by integrating that by parts. That's how we got it the other day. So, oh, this is a definite integral. We haven't had one of those yet. So what do we do with that? We evaluate that, right, from 1 to e. So this is 2 e natural log of e minus 2 1 natural log of 1 minus 1. And I'd put $10 on that. A third of you want to leave it like that because you're afraid to simplify that. Which just makes me sad. What's the natural log of e? 1. So that's going to be e times 1 is e minus e. What's the natural log of 1? Try again. 0. So 2 times 0 minus 2 times negative 1, or 2. A lot of you have been just more comfortable with it. Should you be able to do that? Yeah. You should be able to do that.
Desmos 4.
It would take you, I mean, okay, you don't have Desmos open right now, right? You don't have your Chromebook open. I would bet you I could do that faster than you could get your Chromebook out and even turned on. So I wouldn't say that's a good use of Desmos, right? I mean, getting Desmos out to get 2 there would be like, you have to go to walk to South Unit and you're gonna get in a car, you're gonna walk out to that parking lot, and you're gonna get in your car, and then you're gonna drive around the building, all the way out on the Troy Road, and then drive down Schroyer, then come down, enter into the parking lot over by the Career Tech Center, park your car, get out, and then walk into something. And it uses gas. Other questions? One's from the homework. Let me get out. What do you mean? Well, I'm going to give you some on Delta Math to practice tonight. So, like that's, I haven't created the assignment yet. Delta Math has some that you can practice on. So that's good because you can check yourself. Oh no, that's too bad. Now you got to be cautious with Delta Math. Remember, you might have done it right, but didn't like how you wrote it. I mean, if you wrote that on Delta Math, it's going to say, try again. Maybe not. I don't know. It should kind of give you like a kind of a disappointed like look at you. So we're good on those problems, right? So if you can do the ones on your homework, you should be able to do any one on the quiz. Like, because they're going to look like that. And probably there'll be some of the more simpler ones, not the real complex ones. If in an ideal world, we would have had that quiz today. And this is for me getting used. I have to get used to this not having Wednesday thing. Like if this were a normal world, that quiz really should have been today. I mean, I wouldn't spend more than a week on integration by parts. And now we're getting close to it. Okay, let me give you this. This is not integration by parts necessarily. This is what our book calls integrating powers of trig. It doesn't use the word trig, but let's start with an easy one. This one you should be able to do. Easy. Not even a trick to it. Anybody got it already? You should be able to get it pretty quick. Have confidence. Yeah, sorry. This is not integration by parts. And of course, you're now thinking, well, how am I supposed to know? Which one is it? That's part of knowing it. Knowing which one it is. So how do we do this? Ross, how do you do this?
Do U sub.
U sub, what's U?
Sine of x.
U is sine of x. Du is cosine of x. Money. Look at that. U cubed du. This is like textbook U sub, right? U to the fourth over 4, so sine to the fourth over 4 plus a big old bag of chips. Okay? What about this then? How's this fifth one? What's the obvious difference? Cosine is squared. And apparently that's problematic. Or else I wouldn't be showing this to you, right? I mean, there's some issue there that. So why is this an issue? Why is that cosine squared an issue? Why can't I do it the way I just did the last one? Yeah, du is cosine, not cosine squared. And we're not going to have du squared. That's not real kosher. So this one's a little different. You guys see that? So we got to get creative. And typically creativity, when trig's involved, means identities. God love the trig identities. Any psych job. Do we know any identities, trig identities? You know the big ones. Sine squared plus cosine squared is 1. Oh, I thought you didn't know any. It stops there. But if you know that, you know 2 more. 1 minus cosine squared is sine squared. 1 minus sine squared is cosine squared. 1 plus tangent squared. Squared. Yep. 1 plus cotangent squared. Cosecant squared. Wow, we know all of these. Okay, ready? So here's what I'm going to do. I'm going to first write this like that. And you're thinking, well, why did you do that? You'll see. Then I'm going to write it like this. I'm going to borrow. Anybody have an idea what I'm going to do now? I'll tell you this. This will give you a hint. The goal here is to still do this with a U sub. I want to do it with a U sub. That sine of x that's hanging out there on the end, he's serving the same purpose as the cosine did on the first example. But I got to do one change. You're going to change that sine squared into 1 minus cosine squared? And now watch this. Let u equal cosine of x. What's du? Negative sine of x. So this is u squared times 1 minus u squared du. But, oh, it's negative, so I'll stick a negative on the outside. Can you do that? Now, yeah, I will be honest, it's not uncommon for us, because some of these get so complex, we start looking at ones that are really easily through a complex glasses, and you think a problem is much more difficult than it is. This is actually really, really easy. But if you're thinking integration by parts and stuff, you might miss the easiness. What do you have to do to this to make it really easy? Distribute. So it's negative u to the third over 3 minus u to the 5 over 5 plus the chips. And then go back and resubstitute. What was u? I forget. Cosine. So we're probably going to get to that one. But what was the strategy there? What was the strategy that we used? I had a powers of trig functions, right? The goal was to get it all in terms of cosine and then use that sine as the du. You see how we did that? You could have done it the other way, or it's possible we might have had to do it the other way. Put it all in terms of sine and then use the cosine as the du. But that wouldn't have worked here. Why? Why couldn't I put this in terms of sine and then use the cosine as du? It has something to do with the odd and evenness powers. We'll discover that tomorrow. So I'll give you some Delta math practice and a little quiz tomorrow, like 10 minutes, 15-minute deal. Nothing like, it's only going to be a few problems. But I got to make sure you're keeping up on this stuff. You know? I don't want you slacking. Give me glass. So Becca, how did you get so famous? I know that, but like, how does that?
I don't even know.
How did it start?
I just started painting stuff from like day one.
You paint, and that's how it started. And you're just making videos, right?
What's up? How was your Wednesday?
How was my Wednesday?
Yeah.
My Wednesday wasn't too shabby.
Good.
How was your Wednesday?
It was good. My dad has clients in Japan, and they sent us a bunch of candy. So I got a bunch of candy.
What did you get? Let me see. I spent 6 weeks in
I
Japan.
got this. We got a bunch of like Taki. I like the strawberry ones. We got.
Oh, I think I know what that is. I remember that.
Yeah. We also got like a maple syrup flavor. And then we got this like fish paste thing.
That sounds disgusting.
It looks disgusting. I haven't tried it yet. And then we got these like death sauce chips that are disgusting.
What does your dad do that he has clients in Japan?
He's an engineer for Kodak, and they sell like large scale printers. So, and like his team like makes software to solve what problems for it. So, yeah, he's been to Japan a bunch of times.
Yeah, I went when I was in college, in '96.
Hi, Jimmy.
Yeah, he goes to Rochester all the
Are you
time.
going to Wally's house after?
He goes to
The
Japan.
answer to that is yes.
Israel. I don't know, a couple other places.
I didn't spray your desk.
I'm going to stop at my house because
You're
I
already
don't live
back.
that far and pick up my razor and.
Are you guys shaving your heads for sectional?
No, we're shaving our legs, arms.
Oh, you're shaving up.
Yeah. I'm not shaving my head.
I went on a mission trip when I was in college. Shaving our heads for districts possibly.
No, we're going blonde for this.
Oh, Lord.
Yeah. Blonde for districts, shave for sectionals. Yeah, there's like a whole group of boys going to Wally's house and we're gonna have a
That sounds like a super spreader.
A what?
That sounds like a super spreader event. Are you guys gonna wear masks and stay 6 feet apart?
Probably not.
Well, you should.
Mitter, have you ever gone bald? Like fully?
Have I ever shaved my head bald?
Yeah, like no hair. whatsoever.
No, I mean, like I'll use a number 1 sometimes, but I've never gone a no guard.
If we make it to state where you shave your head, like
I would easily shave my head from the state.
Alright, let's do it. Still, you heard me.
I mean, I think there would have to be about 16 relays ahead of you that get disqualified.
Yeah.
Whoa,
For us to
whoa.
make it to
Have
state.
faith. Have faith. We're gonna pull out the best time.
St. X's 400 free relay time is a 3:07.
Alright, so we all got about 10 seconds. If we can beat them.
I wish I had something.
Actually, I'm creating a spreadsheet right now.
You're telling me they average a 45?
Well, let's talk about the boys 100 free.
St. Nick's was crazier.
St. X has a boy that goes a 46, a 47, a 47, a 48, and another 48. Those are their 4 entries.
Those are their 4 entries.
That's the 4 entries in the 100 free. That's not necessarily their 4 fastest 100 freestyle.
Yeah.
Their boys 200 free relay, 200 free relay. Their entry time is a 124.
How does that even work?
Their 400 free relay, their entry time is a 3:07. Now, interestingly, Beaver Creek is only a second behind them at a 3:08.
Yeah, Beaver Creek's kind of fast.
Yeah. Did you guys play Select?
What?
Did you play Select?
Now, I'm not sure the time that we have entered. Do you know what our fastest 4 free relay time is?
The fastest 4 free?
Yeah, this
It's
year.
It's like a 3:40, I think.
Because it says 3:30 in here.
Yeah, we're not quick there.
If it's a 3:40, we'd be sitting at 25th.
Oh, by how much?
Right on nose.
How many people are in
Well, when I say 25th, what I've done is my spreadsheet that I've made is all the sectional sites. All, for boys, I think it's 7. All 7 of them, and I took all of the site sheets from all 7 and put them into one spreadsheet and then ranked them. So if ours is a 340, then we would be sitting at 25th, which means we have a legitimate shot because you have no idea how many of those times are made up.
Yeah.
Like, they could be made up times that could be a fastest time from 2 years ago. You just don't know.
And how many go to districts? How
24.
Okay, and then from districts, how many go to state?
From districts, there's automatic qualifiers to state. So
Yeah, the top 2.
So
are
it's the
all
top 2 from
qualified.
each district, so that
Yeah.
makes 8. Then the next 16 fastest times to make a field of 24.
And how many districts are there?
4.
So just be top 4.
How many people do you think are going to compete in the 500?
Yes.
Actually, 500 is the next one I was going to do for boys. For the boys 500.
Let's go, Billy.
All right.
100, yes, sir.
My guess to qualify for districts in the boys 500, you probably need to be going like sub 510.
Oh my god.
Would be my guess. Because the state qualifiers are going in the 4s.
That's insane. That's ridiculous.
So, like Southwest Ohio is ridiculous. It is ridiculous in Division 1. And you'll hear people argue. You'll hear the people that go to Oakwood, and you'll hear the people that go to Albany. Oh, it's the same to get to state as it is in D1.
No.
If you look at the times, they're similar. Yeah, no kidding. They are similar. But you have to look at the number of people that you have to beat.
Yeah.
Like in D1, you have 20 people competing for 4 spots in Southwest. Versus in D2, you have 3 people competing for 4 spots. Like, yeah, so they have similar times, but it's not even, if they take top 16, like if they take the 24 and you take the automatics out, and then the next 16 fastest, if you look at those 16 times, they're all like super tightly packed.
Oh, yeah.
And then if you look at their districts that they all came out of, there's a whole slew of times that they beat that were right there next to them. It's just, these people are crazy. They're just trying to defend their easy path. Of course, if we were there, we would be doing it.
Yeah, why don't we just change
I don't know.
not Division 1?
Yeah, I don't understand how Bellbrook is D1 for girls, but not boys.
What?
Yeah.
That's a thing.
Somehow they became D1 in girls.
All right, let's drop. Let's
Is there a way
drop
that
our
we can
boys to
become D2?
Let's drop our boys to D2.
I want to drop our girls to D2. And then our relays would be maybe potentially talking about state.
Yeah.
Um,
Good old Steve.
Anyway, well, let's move on. So here's what I want to do today. I want to show you the rapid integration by parts method. I want to answer any questions that you have over homework problems. I want to also start the next section, which is talking about integrating powers of trig functions. We're going to have a little integration by parts quiz tomorrow. Tonight I haven't created the assignment yet, but we'll have an assignment on delta math. That's integration by parts. Just doing integration by parts practice. So that'll help you study for the quiz. So yeah. Are y'all ready? Y'all ready for this? So I call this a rapido. Rapido. This is the shortcut method. So let's try example. X cubed e to the 3x. Is that where you're gonna go? You see?
Yeah, I found out fast. Their decision date is February 5th.
Wait, you find out if you're gonna get accepted?
Yes.
Oh.
Well, I'm
You're gonna get accepted. I mean,
well, the nursing program.
oh, nurse. Okay, that's a little. Yeah, okay, that's a little bit more competitive. But I still think.
Yeah, I'm not in anywhere else.
All right, so if you know what you're doing, and you're on top of things, you're looking at this problem and you're thinking, oh, I don't want to do this. Because in order to do this, you have to do integration by parts 3 times. No one wants to do that, right? So this isn't a good place where we would use this shortcut technique that I call rapido. Okay? Also known as the tic-tac-toe method. So what you do is you make 2 columns. You make a U column and a DV column. Okay? In your U column, you put what your choice for U would have been. Which would be what? X cubed. And in your DV, you put what your choice for DV would have been. Which would be e to the 3x. Okay? Then, in the U column, you differentiate this all the way down until you get 0. Okay? And in the DV column, you anti-differentiate. So now you got to be able to do antiderivatives pretty easily and quickly. When you anti-differentiate e to the 3x, you get e to the 3x over 3. And when you anti-differentiate e to the 3x over 3, you get e to the 3x over 9. And when you anti-differentiate e to the 3x over 9, you get e to the 3x over 27. And when you anti-differentiate e to the 3x over 27, you get e to the 3x over, 81. Where are those numbers coming from? why am I multiplying by 3 each time? That's we need to be able to see that.
We have to take the derivative of the 3. Or when you would do substitution, have that u equals 3x, then do the derivative of that, which would be.
Each one of those is a little u substitution. As you go down, each one of those is a little u substitution. So it's the first one's du over 3, the second one's du over 3, the next one's du over 3, and each time you have an extra 3. Okay? All right, so we're not done. Next step is we draw arrows from here. We skip this guy right here. He's a loser. Draw arrows. Now you could draw an arrow back to 0, but you don't need to. And then we go plus, minus, plus, minus. You just alternate signs down the road. You could end on a negative, you could end on a positive, depending on how many arrows you have. And then basically, friends, the arrow means multiply. And then the plus or minus says what you do from term to term. So here we go. X cubed times e to the x cubed over 3. I'm sorry, e to the 3x over 3. Minus 3x squared e to the 3x over 9. Plus 6x e to the 3x over 27 minus 6 e to the 3x over 81 plus chips. We're done. Okay. You like that? I mean, I'm kind of a fan.
I was hoping we would have something on like the same order of magnitude as the x derivative trick we learned. I think that's
I mean,
about it.
like x to the n.
Yeah, like
Oh.
how we learned with that.
I mean, that's not really so much a trick as it's a rule. But yeah.
Can we see an example where it's like wouldn't work?
Yeah, we will. So now you're gonna try one just for fun. You're rapido. Now you got to be mindful of your signs. You ought to be mindful of your signs. I'll work it out up here while you guys keep working. Uh-oh. Let's do that up. No. So this is. How do we do? So when two negatives are in there, you marry them and make a positive. Do we like that? Rapido? So when does this work well? Okay. I, Scott Mitter, would use this when I have a power, like x cubed, x to the fourth, x to the whatever, times an exponential, like e to the x, e to the 3x, e to the 7x, but not e to like some x squared or x cubed. I wouldn't do it then. You'll see why in a second. Or if you have a power like x cubed, x to the fifth, x to the seventh, whatever, times a trig function, sine x or cosine x. That's when it's the most efficient. You can use it in other cases, but it involves too much thinking midstream. And if it's a shortcut should not involve a lot of thinking midstream. Like it should be a shortcut, right? So you want to see one where it doesn't work? Or, well, actually, where it still will work, but it's just clunky. I don't like it. So if you're thinking about doing this with the Rapido, what do you want to make u? X cubed, and then you want to make dv e to the x squared. Okay, but there's a problem with that. There's a problem with that. The problem with that is do you know the antiderivative of e to the x squared? Because I sure don't. I don't know the antiderivative of e to the x squared. Now, someone who's new at learning u subs and antiderivatives might think the antiderivative of e to the x squared is e to the x squared divided by 2x. But why is that not the antiderivative of e to the x squared? That looks really crappy. Billy's looking at that like, what? Why is this not the antiderivative of e to the x squared? There's a simple answer. Because the derivative of that is not e to the x squared. If you took the derivative of that, you'd have to use a quotient rule. And that is nowhere even closely going to simplify e to the x squared. Okay? In fact, my friends, e to the x squared, it actually doesn't have an antiderivative in closed form. Like, you can't write the antiderivative of e to the x squared as a function of e to the x or anything like that. It doesn't exist. Okay? So crap, what are we going to do? Well, we're going to go back to elementary school. Back when life was easy. And our only care in the world was whether we got picked for dodgeball. Maybe that wasn't easy. Maybe that made it traumatizing. But do you remember elementary school? And if in elementary school, you learned how to do this, 50 minus 19. Now you probably just use a calculator to do that, right? I mean, you wouldn't do it by hand, you just use a calculator. Got it. Please tell me you're not using a calculator to subtract. Even I wouldn't do that, and I suck at arithmetic. But when you learned 50 minus 19, what did you have to do there? You had to borrow, right? You remember borrowing? Okay, they don't call it borrowing anymore. If you have elementary school siblings and they're learning this, they don't call it borrowing anymore. They call it regrouping. Even that term is a little What's really happening when you borrow, and this is probably the reason why we don't call it borrowing anymore, is, you learn this, I changed this to a 4 and then make that a 10. And then I say 10 minus 9 is 1, 4 minus, that's 31. Okay. Yeah, I'm good at math. I don't know, have any idea what I just did and why it works. But I got the right answer, so I'm good at math. Sadly, that's the world that we all grew up in, including you guys. I mean, I think as you guys were in elementary school is when things started changing. Like we started looking at this saying, is it as important for them to get the right answer as them knowing what the heck's going on there? What's going on when you change that 4 and make it out a 1? What's actually happening? Can anyone tell me that? Okay, what did you say?
Breaking up between, it's 10 and then 40 and then 10 minus 9 and then 40 minus 10.
Right, you're renaming 50. You're calling 50, 40, and 10. Right? You're taking 10 away from that 50, and you're regrouping it. Right? I'll 100% God's honest truth. When I was in elementary school, I did not know that. I had no flipping clue. But I could cross it out and change that. Same, don't even get me started on long division. What the hell's going on there? I mean, seriously. You start doing all these things with long division, you have no clue what's happening. You're just doing, I got the right answer. I know, I'm good at that. No, you're not. So I'm going to do something similar here. I gotta watch my swearing. I'm on the internet here. Okay? I'm going to do something similar here. I'm going to borrow an x. I renamed x cubed as x cubed times x. Why would I do that? I'm sorry, x squared times x. Thank you, Sam. Why would I do that?
It's pretty easy to do each or x times each is x squared. You can use substitution.
Because this right here is an antiderivative I can do. I couldn't do it when it was e to the x squared. So now let's do it by parts. U is x squared. dv. We're not going to do it rapido. We're just going to do it regular. So then what's du? 2x dx. What's v? Okay, now, we might have problems finding this v. We've got to be able to do that u sub. Maybe we need to work it off to the side. Okay? Maybe over here, off to the side, we just quietly, we sneak off into a corner over here and do this by ourselves, and we don't tell anybody. Because we're ashamed we don't know that in our head. No, you don't have to know that in your head. Just work it off in the side. No big deal. So here it is. U is x squared. Du is 2x. So du over 2 is x dx. So this ends up being e to the u du over 2. And what's the antiderivative of e to the u? E to the u. So that's 1/2 e to the x squared. Okay? Well, we're not done. Now we got to finish out the integration by parts, right? So u times of e, 1/2 x squared e to the x squared, minus the integral of v to u, 1/2 e to the x squared times 2x dx. Can that simplify before I do anything calculus-wise? Doesn't that just simplify to x e to the x squared? Oh, wait. Didn't we just do that one? We just found that antiderivative 5 seconds ago. What is it?
Over 2 e to the
Okay. So why would we want when we do this using the rapido method? Think for a second. Why would this be weird? Because you have to do that borrowing like in the middle. Right? You got to set it up that way. And, I mean, honestly, and if that were x to the 5th e to the x squared, then it would have been really messy. Because we would have had to borrow twice. We would have had to borrow once at the beginning, then we would have had to borrow once in the middle. Technically, they don't call it borrowing, they call it reassociating factors.
That's I think they should say in elementary school too, just to relate.
Regrouping?
They're just
Yeah.
reassociative factors.
But honestly, think about this for a second, people. I'm going to get on a little soapbox for a second. If you really teach kids math and not just answer getting, and you really teach them to understand what that is right here, this is not a stretch. Like, it's not a big stretch to rewrite that as x squared times x. And to think to do that. If you grow up thinking mathematically, it's not a stretch for you to you would think on your own to do this. Sure, if I show you, hey, do this, you're like, yeah, that makes sense. But it's a different thing for you to sort of think of it on your own. You're much more likely to think of it on your own if you've had experiences like that along the way, right? I mean, that's why we should be teaching math, not answer getting. But sadly, we just teach a lot of answer getting. Like, oh, math is arithmetic in elementary school. If you get the right answer, you're good at math. Okay. So, do you see what I mean by rapido there would not be real favorable? Okay, does anybody have any problems they want me to work out? You know, no one reached out to me yesterday with problems they wanted me to work out, except one person in the last period. I had a little Zoom meeting with one person yesterday and worked out all the problems. So I didn't know if I should be concerned or excited. But anyone didn't want me to work out from their homework? We good there? We not good? Yeah.
Are there any other examples of problems where rapido wouldn't work? Maybe like some form of sine or cosine or anything like that besides e?
I probably wouldn't use the rapid method unless it was like x squared and sine of x.
So if there's an x to something.
It's a power of x and a trig function. But that trig function needs to be just a regular trig function, sine of 2x, sine of 5x. If it's sine of radical x or sine of x squared, nah, that's going to get too complex. Or if it's a power of x times an e to the x, like an e to the 2x, e to the 3x, that sort of thing. That's the only time I would use it. It can be used on almost any of them if you rearrange things in the middle. But at some point, like if you're doing all this rearranging things in the middle to make that technique work, it gets too complicated. It's no longer a shortcut. You might as well have just done it the other way. I mean, I don't want to, a shortcut is something that you don't want to have to really think about. It should just be like that. Yeah.
So we have like a whole problem that's like similar to the example we just did.
Yeah.
But it's like e to the negative x squared, so would the answer just be -1 half instead of like 1.
Well, what else is in that problem?
It's the same thing. It's like integral of x times e to the negative x squared. So would the answer just be like -1 half e to the x?
Yeah, so if it's x e to the negative x squared, I mean, that's just a u sub. So u is negative x squared, du is negative 2x. So it's going to be the exact same as, but that negative is going to cause the answer to be negative. So Miami University sent me and my wife these masks. And like if you are what they call a Miami merger, means that both you and your spouse went to Miami. Somehow they find this out, and then every year at Valentine's Day or around Valentine's Day, they send you something. Sometimes it's just a little card. I mean, if there've been a few years where it's been a little trinket of some sort. Well, this year they sent these masks. It's a Miami merger, somewhere around here. So yeah, it's all cheap, but I don't like this thing here. Ugh. You guys wear masks with these like, I don't like that pulling on my ears like that. It's very uncomfortable. And it's also very hot. But I match my wife. No other questions? So we're going to practice some delta math tonight on integration by parts. We're going to start the next topic now, which the book calls Integrating Powers of Trig Functions. We've already done some of these, actually. We're just going to make them a little tougher. And then we'll have a little quiz tomorrow. We'll have some homework problems over integrating powers of trig for the weekend. Just rolling along here. How to, baby. These techniques of integration, at some point you're going to be asking yourself, how do I know if this is integration by parts, or how do I know if this is a u sub? Right? I mean, are you thinking that now? Like, but that's what it means to know it. Like, that's really what it means to know it, is when you know that distinction, like you've done enough of them that you recognize, okay, integration by a u sub is not going to work here. Like, or integration by parts is not going to work. Because you will have done enough of them and you can see the kind of the problem develop. Now, I will tell you, most of the ones that we're going to do right now in this next section won't be integration by parts. They'll actually be u subs with a twist. Okay? So the book calls this integrating powers of trig. That doesn't use the word trig, but I like trig. Okay, so let's start off with an easy one. You ready? In fact, this is one that you all should be able to do right now. I mean, you should look at that and own it. Like, Elias, you're way back there in the back, all by yourself. Do you like it back there? I mean, do you want to move? You don't feel like a loser or anything? Okay. This problem is screaming. What? Use of. It is screaming use of. It's like on fire use of. What's U? Sine of x. Du. Cosine of x. This is like textbook use of. U cubed du. U to the fourth over 4. Sine to the fourth x over 4 plus chips. Give me something that's different. Right? You like that? Okay, let's kick this up a little bit. So what's the difference between this one and the last one? What's the obvious difference? The cosine is squared. Now, why is that problematic when it comes to doing this as a U sub? Why does this make me shiver when it comes to doing this as a U sub? Billy, what were you going to say? There's an extra cosine, right? Du is cosine, not cosine squared. And I don't think we've ever done anything with du squared before, like that ain't gonna fly. So we have to get creative. Okay, now I will be honest, getting creative, when trig is involved, getting creative more often than not means using identities. Right? Do we know any trig identities? Sine squared plus cosine squared is 1. 1 minus sine squared is 1 minus cosine squared is 1 plus tangent squared is secant squared. Billy like took him a second. Secant squared. 1 plus tangent squared is secant squared. 1 plus cotangent squared is cosecant squared. Okay, those are the biggies that we're going to be using here. So I'm going to do this. Maybe I'll borrow again. Let's do this. The first thing I'm going to do is I'm going to write this as cosine squared times sine cubed. And then I'm going to write this as cosine squared times sine squared times sine. And you may ask yourself, why did you do that? Do you see why I did that, Billy?
No, I'm confused on why cosine squared became
What?
cosine squared became cosine cubed.
Oh, that's because I'm stupid. Okay, so if you don't see why I did that, let me give you some insight as to why I did it. You see that sine of x hanging out there on the end by himself, like Matthias? That sine of x is going to serve the same purpose as the cosine served in the last problem. That sine of x is going to be the du. So if that sine of x is going to be the du, that means I got to get this entire problem, except for that sine of x, in terms of what? Cosine. Can you do that? Sine squared is AKA 1 minus cosine squared. And now, I'm not going to say that this one is screaming use of. This one is whispering use of. Because it's not quite as obvious just because of the way it's written. But you can, in fact, let u equal cosine of x. And what's du? Negative sine of x. So that's u squared times 1 minus u squared du. And then I'll stick that negative on the outside. Now, sometimes after you've integrated by parts for a while and you've done some substitutions, like sometimes you start to overlook the easy problems and you start to make them more complex. And this is a case where that might happen. This integral right here is actually super easy to do, like ridiculously easy. But it's very easy for us, especially you, to not see this as easy because you've been doing some more difficult ones. But I heard Nicole say it. She whispered it. If you distribute, look how easy that is. So what's the antiderivative? It's negative u cubed over 3 minus u to the 5 over 5, right? So now go back and put in your starters. What was u? Now, can you write that as cosine of x all cubed or cosine cubed? It doesn't matter. I don't care. Plus chips. Yeah. Okay, so let me ask you this before we part ways. I had to do it this way. There was no other way for me to do it. And you might think that reversing that and putting it all in terms of sine and leaving a cosine might have worked. Why wouldn't it? Why couldn't I have not put this all in terms of sine and left a cosine dangling on the end, like Matthias? Alex, what do you think?
There wouldn't be an extra cosine left to add at the end?
Why?
Because it's sine cubed, so you can turn it into sine squared times sine of x. With cosine squared of x, there's no extra cosine to add on the end.
So it has something to do with the even and odd powerness of the sine and cosine, right? You see that? Yeah.
Like, using integration by parts, then you to cosine and dv to sine cubed x cosine x, and then eventually get to 1/4 sine to the fourth x cosine x plus 1/4 integral of sine or dx, and then.
But do you know the antiderivative of sine to the fifth?
Well, I could use that method of solving like that. Like that method of solving.
Could I use what?
Like that method of solving like sine to the fifth. I feel like you could probably like put off like a sine squared and then
Use the method that we just did
yeah.
to find sine to the fifth? Yes, we could do that.
It wouldn't be the most like.
Oh yeah, I mean that would be, you could get the right answer doing that way, completely not efficient, but yeah, you could get there. I mean, it's like, it would be the equivalent of saying, I need to get to South Unit, so I'm gonna walk out here, I'm gonna get in my car, I'm gonna then drive my car down out onto the lane, then I'm gonna turn right on Destroyer, then I'm gonna go sit at the light at Lincoln Park, and then I'm gonna turn right into the parking lot, park my car, get out, walk into South Union. Like, I mean, whereas I could have just walked across the courtyard. I mean, yeah, it's definitely works, but, hey, see you later. Peace be with you.
I'll see you later, Bitter.
Don't worry, I'll be back. You'll be back. Because really, Nicole, what you're doing there, each time you do that antiderivative, is you're doing a little u substitution. So it's like du over 2, du over 2, du over 2. And each time there's an extra 2, it's du over 2 times 2. Then it's du over 2 times 2 times 2. Then it's du over 2 times 2 times 2 times 2.
Okay. That makes sense. Just wanted to- I'm going to lunch. Yeah, I do.